Hello, Algebra. I am, I don't know why I'm turning my volume up. It's probably not going to affect you, but you might be wondering and sitting there going, that's kind of strange. Mrs. Silva has half the page filled out. Yeah, that's because I already did all that on a different video that was not recording. So, although that's not a surprise to any of you because you know how I am with technology. But I have grabbed my own computer and not the work computer, and now it seems to be working fine. So we're going to try this again. So some of it's written in, but then at number 10 it's not. So we're going to start at the beginning here though. Sarah drives 55 miles per hour for H hours. Which expression, remember expression does not have an equal sign, shows the number of miles that Sarah drove. So now we didn't use distance equals rate times time, but I know you've seen it in the past. I know you've seen it in science, and it's telling you you're going 55 miles an hour. So if you go 2 hours, how many miles did you go? It's 55 miles per 1 hour, 110. So in this case, you're multiplying the 55 times the time, the rate times the time. So it would be 55 times h, because remember that is a multiplication in there. You would not add it. Next one, what is the correct verbal expression for this? Okay, and I had gone through saying it can't be quotient. Quotient means divide. It can't be product. Product means multiply. And it can't be less than, because less than is subtraction. 9 less than n would be 9 minus n. The product of 9 and n is 9n. The quotient of 9 and n is 9 divided by n. But this is n more than 9. That is addition. Remember the word sum also means addition. And the word difference also means subtraction. So you need to make sure you know all those special terms that we use. Evaluate. Evaluate means find the answer for m plus n, where m is 5 and n is 4. So we just substitute 5 in for m. We substitute 4 in for n. We add them and get 9. Number 4. We are following our rules here. So negative 11 plus 23. This is the one where you have a negatives and you have positives. So we have a little fight going on. And who wins the fight? The negatives or the positives? The positives win. Why? Because they have more. How many more does this team have than this? Well, just subtract them, 12. The next one says subtract 32 minus 15.5. And what I had reminded you of is, yes, you can just go over here, 32 minus 15.5. But remember, subtraction is always the same as adding the opposite. So that is what I was just being consistent there. But remember, when you subtract, you got to have your decimals lined up. And you might say, but there's no decimal there. Yes, there is. Remember, it's always at the end. So 32 decimal, 15.5. So I need to add a 0 in here so that I can subtract straight down. So I wrote 10 and borrowed here and got a 1. 10 minus 5 is 5. And then I went up here and I had a 1 minus 5. Can't do it, so I had to borrow again. And the guy next door, good thing he's got something to loan to us. We have 11 minus 5 is 6, and 2 minus 1 is 1. And then, of course, carry your decimal down. Don't forget that. Then we had here, I'm going to rewrite it, 3 minus 15. Subtracting is the same as adding the opposite. So again, we're in this deal where we got the positives and the negatives. Got a little fight. Who wins? They do, because they have more. And how many more? 12 more. 7. It does say to multiply, but you should have known to multiply anyway, because negative 2 with a parenthesis here means there's a multiplication right in there, isn't there? So negative 2 times 9 is a negative 18. Divide. Negative 4 divided by negative 16. Remember, you can write this as a fraction. It doesn't mean you have to do long division. We're just simplifying here. So negative 4 divided by negative 16. Negative divided by a negative is a positive. And the 4 and the 16 can be simplified by dividing by 4 and getting 1, dividing by 4 and getting 4. My answer is then 1 over 4. And you don't have to divide 1 divided by 4. You can just leave it like this. It is 0.25, but you don't have to do that. Dividing fractions. Remember, we did a whole worksheet on practicing all the different rules with fractions just to make sure you didn't forget. When you're dividing, it's what? Keep, change, flip. Keep the same. Change from division to multiplication. Then flip or take the reciprocal. Now you can cross cancel or up and down if you could, but you can't. Nothing simplifies. So 3 times 5 is 15 and 7 times 7 is 49, and that's your answer. All right, so we're on now to the next one where we left off. I'm going to check, and yes, indeed, we are still recording. So life is very good right now. Make sure that's good and clear. 210 students attended. Wait, I got to change back to my blue. 210 students attended the school dance. If each ticket cost $15, how much money was spent on tickets? So what operation would you need to do here? Each of these is $15. Correct. You got to multiply. So I'm going to go over here and do my multiplication. 210 times 15. Remember, you start with this one first. 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. Go to the next row because I'm now going to look at this. So I got to fill this with a 0. Now begin. 1 times 0, 0. 1 times 1, 1. And 1 times 2, 2. I'm going to add them straight down. And I have my answer. They spent a whopping $3,150. 11. Simplify. 1/2 raised to the 4th power. So anything inside raised to the 4th is 1/2 times 1/2 times 1/2 times 1/2. 1 times 1 is 1, times 1 is 1, times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 10 to the 3rd. Yes, that is 10 times 10 times 10. 3 times. But there's also a little trick. How many zeros are there in 10 to the 3rd? 3. So the answer is 1,000. But if you forgot that little trick, you can do 10 times 10 is 100. And then 100 times 10 is 1,000. Number 13. Remember, this is the square root. And you can break the square roots up. So I can look at the top and bottom each separately. You don't have to think of it as a fraction. That's kind of confusing. But you can think of it this way, and then it's not so confusing. Because what's the square root of 4? 2. And what's the square root of 9? 3. And we're all done. Which of the following is a whole number? So I want you to try to remember what's the very bottom of our, just going to turn this over for a second. Remember we had at the top, we had reals, and then the reals dropped off into what? Irrational and rational. And then the rational dropped off into repeating, decimals, and terminating decimals. And then under the decimals came what? Integers. And under the integers came whole numbers. And under the whole numbers came counting, or there's two names, natural. numbers. The only difference between counting a natural and whole was one number. Because counting, you start counting at 1. So this would just go on. Whole numbers include the number 0 and go on. And integers include the negatives. Okay, so those are the more specific ones. So now let's see what was the question. Which of the following is a whole number? So -2, let's look. Nope, -2 is an integer and up. Oopsie, whoa, okay. 4.1. Nope, 4.1 would fall where? Terminating decimal. 3. Where would 3 fall? 3 would fall here. So remember, since it's this, what else is it? It's also a whole number. It's also a integer. It's also a terminating, rational, and real. Remember, it's everything above it. Okay, so currently that is our answer. Let's just check pi and see where that would fall. Pi would fall over here, along with like square root of 28 or something like that. Repeating decimals would be like 0.3 with a repeater bar. Terminating decimals are like 1.5, ones that end. Okay. So, good job. Which one is not an integer? Okay, let's refresh our memory on the integers. It was 0, 1, 2, 3, 4, 5, 6, blah, 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 and -1, 2, 3, blah, 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 blah. All those are integers. Nothing more? So let's see. Square root of 16 is 4. Is that an integer? Yes. Oh, I gotta look for the one that's not. Okay. 0, is that an integer? Yes. Is -4 an integer? Yes. The only one that is not is this. And that is a terminating decimal, one notch above the integer. The rest of them all fell in this category. Good work. All right, it's time for a break from our what is it called? A time for a word from our sponsor. Our sponsor today is Zevia. Zevia, when you need a break and you want something healthy that still tastes good, but it's good for you, have a Zevia. Recommended by all math teachers everywhere. Cola primarily. There is 0 sugar, and there's not garbage in it. If you look closely, what's in it is come on now. There it is. Stevia leaf. Yes, stevia leaf. A natural leaf that helps to sweeten things while keeping you healthy. Back to algebra. A square rug has an area of 36 square feet. How long is one side? Square, draw yourself a picture. Area, 36. Now remember, you're not dividing by 4. and telling me 9. That would be incorrect. That is if I would have said perimeter, okay? I'm talking area. Remember the formula for area of a square? It's s to the second. So how do you do this? If you know the area is 36, how do you work backwards and just get one side? You square root both sides. 6 feet. Okay, so if I tell you the area is 25 square feet, that means one side is what? What if the area is 25? One side would be 5. What if the area is 100? What's one side? 10. Good. All right, order of operations. How many operations are in here? 2. New pen color, please. We've got addition and multiplication. We do what first? We got PEMDAS going here. So we need addition is right here and multiplication is up here. So we do multiplication first. So 5 times 2 is 10 and my answer is 17. Very good. All right. Next, you see that fraction bar, and that fraction bar tells you this is grouping. Okay, so you got to do this first, and then you got to do that. Then you divide them. Okay, so looking just in the top, order of operations mean we need to do exponents first. So 2 to the second power is 4. 20 minus 4 is 16. That's an equal, not a. And then the bottom is 6 minus 4, which is 2. And now we divide and get the 8. It's the very last thing we do. All right, looking down here to evaluate, x is 3. So we got to take and substitute a 3 in here. And we have to decide what to do first. Okay, and you're going to say parentheses. Okay, great. So I go in the parentheses. Yep, there's definitely something to do in there. We got to do 3 minus 1. So that's 2 to the third power. Now we keep moving, and our next thing is exponents. So do not multiply these and get 4 and raise it to the third power. Then you're doing multiplication before your exponent. So 2 to the third is 2 times 2, which is 4, times 2, which is 8. So I now have 2 times 8, which is 16. Very good. And I'm browning some ground turkey, so I need to take a moment's break. 1 moment, please. All right, I'm back. Nothing burned. That's good news. Okay, which algebraic expression represents 4 times the difference of, and then it tells you the two numbers, 7 and 1. So you're taking the English words and putting them into the math. And the symbols are important. It didn't say 4 times 7. Does it say 4 times 7? It doesn't say 4 times 7. It says 4 times the difference of those. So those got to go in parentheses. That's how it should look. You do not need to figure it out. It didn't ask you to. It says, what is the algebraic expression? Or which algebraic expression represents this? And you wrote it. Okay, this is incorrect. That's wrong. Okay. For 1, you're going to get the wrong answer because this is 6 times 4 is 24. This is 28 minus 1, that's 27. So it doesn't even give you the right answer, but the reason is because it's not 4 times 7. It's 4 times the difference. And when you see the difference or the sum, those got to get thrown into parentheses. All right, let's look at the next one. Which algebraic expression represents k squared more than 10? Okay, so it specifically squares what? Just the k. It doesn't square the 10. So k squared, and then more than is a plus. More than 10, it would be B. 22. Let's look at that color. Where's my purple? Where is my purple? I had a purple. A moment, please. Where's the purple? I'll use this one. All right, the expression b plus 2l can be used to find the perimeter of an isosceles triangle where, okay, so isosceles triangle. First of all, an isosceles triangle is a triangle with two sides that are the same. This expression can be used to find the perimeter of an isosceles triangle where b represents the base and l represents the two legs. Now, you don't even have to really understand this, but I do want you to, because even though we didn't talk about it, we need to start learning what an isosceles triangle is. So it's saying the perimeter is equal to this, the base plus 2 of the legs, right? The base plus 2 of the legs, because they're the same. Well, it says find this perimeter if the isosceles triangle whose base measures 15. So what are they giving you there? What letter? Right, that's your B. And whose legs measure 10. What are they giving you there? That's L. So they mean each of the legs is 10. So I have P equals the base, which is 15, plus 2 times the legs, which are 10. So order of operations, do not do 15 plus 2 and get 17, and then multiply it by 10 and get 170. That would be wrong all the time. You need to do 2 times 10, which is, and I can hear the car, and my son is indeed home. That is 20. So 15 plus 20 is 35. And what's the unit? Centimeters. Okay? So no, you don't have to understand all this. I just added that because what they really did is they gave you a formula and then they told you the B and they told you the L. So it's about substituting that in. Let's look at simplify. When you see a whole long spew of things here, you need to look and see how many different terms you have. We've got 8.5 minus 1 plus 2.5. We have 3 different terms, all of which are just numbers, so we can combine them. Now remember, we can put them in any order, so I think it would be easiest if we combine these two first. Because what's 8.5 plus 2.5? Can you guys hear that car? 8.5 plus 2.5. 8 plus 2 is 10. 1/2 plus 1/2 is another whole 2 halves. So we actually get 11, right? Because these halves put together make a whole. Now I cannot forget though that I still have to subtract the 1 there. And I get 10 for an answer. All right, looking at 24 up here. Again, how many terms? Down here we had 3 and it was slick because they were all numbers, so you can always combine those. But once we add in the variables, you have to have the same exact variable combination to put them together. If you have an x and an xy, you cannot put those together. Okay, because one is x, one is xy. This would have to be an xy. Then I could put them together. If I have an xy and an xy to the second, you cannot put them together. They have to look exactly the same. Okay, so I have how many terms here? 1, 2, 3 terms. Are there any like terms? Yes, there are like terms. We've got 4x and 2x. So we can combine 4x plus 2x. Now you don't lose the x. It's like saying 4 apples plus 2 apples. I don't say I have 6. I say I have 6 apples, right? 4x plus 2x, I have 6 x's now. And this, there are no like terms, so I do put the plus. I don't just write y here. I put plus y. One moment, please. All right, I'm back. Okay, so we are on the next one. Now, up here I said you always want to see how many terms you have. Well, when you have parentheses in here, you have to get that handled first and then evaluate how many terms that you have. So for example, I have 12 times n minus 1. So I have to use my distributive property. I need to take this 12 in the front, and I don't just multiply it by the first thing I see, but I have to also multiply it by the second thing I see. Okay, and I want to also make sure I go in here and change this, because this subtracting is the same as what? Adding the opposite. Okay? So let's do it. 12 times n. Well, I'm not going to write 12 times n. I'm going to just write 12n, because that means the same thing, and we want to simplify it. So we want it written as short as we can. Plus, and I say plus because of this. So I'm going to write this plus sign there. Plus 12 times the negative 1. That's a negative 12. I'm going to rewrite the ending. Plus 2 n. Now that we've gotten rid of the parentheses, we can see how many terms we have. 1, 2, 3. Remember, terms are things that are added or subtracted together. I've got 12n, I've got negative 12, and I've got 2n. Are any of those three like terms? Yes, 2 of them are. This one, because it has an n, and this one, because it has an n. So I'm going to add those together and get 12n plus 2n, which is 14n, plus, and now this one, I cannot combine. You cannot put a 12 and a 14n together. I don't know why that little thing is there. That is not a negative sign there. So that is my answer. You could also write that as, yeah, that's the same thing. But I don't know why that's there. That's not a negative sign. Okay, onward, the coordinate plane. So it does say to use this plane for questions 26 and 27. So make sure you read the directions so that you know what you're doing here. What are the coordinates of point A? So we always do remember x first and then the y. This is my x, this is my y. Okay, so let's go. We do this direction first, so I'm going to go over 1, 2, 3 over, and 1, 2, 3, 4 up. Remember, this is positive direction, this is negative direction. This is positive direction going up, this is negative direction going down. Don't forget your parentheses. Now it says, what quadrant does B lie in? Well, remember, quadrant 1 is up here in the upper right, and then we go counterclockwise. So this one's quadrant 2. You got to remember these. This is quadrant 3, and this is quadrant 4. And if anything falls on here, we say x-axis, and if anything falls on here, we say y-axis. So let's look where B is. B is right here. Which quadrant? That is the second quadrant. So I find 1, 2, and I circle that. Okay? Now make sure that, well, actually not make sure. Tell me what the coordinate B is, since we're practicing. Can you write the coordinate for B down? You should have gotten, start at 0, 0, negative 4, positive 2 for an answer. All right, last question, then we're done. Generate and graph, two things, ordered pairs. So when I say generate, I want to see the XY chart. And here's the equation they give you. They don't give you any x's, so you get to pick. Okay, so we're going to pick negative 2, negative 1, 0, 1, and 2, because that's what we usually pick. Now you're going to substitute in what's the operation between these. It's multiplication. So I am going to now leave that open, and I'm going to use a pencil and put in the answer. So if I put a negative 2 in here, what do we get? 2 times negative 2, negative 4. If I put a negative 1 in here, what do we get? Negative 2. If I put a 0 in here, what do we get? 2 times 0 is 0. If I put a 1 in here, 2 times 1 is 2. And lastly, if I put a 2 in here, 2 times 2 is 4. Now all I need to do is graph them. So I've generated the coordinates right here. This is negative 2, negative 4. This one is negative 1, negative 2, 0, 0, 1, 2, and 2, 4. So negative 2, negative 4, negative 2, negative 4. Negative 1, negative 2. 0, 0, the origin. 1, 2. And 2, 4. Oh, well that's pretty clear. What is that making? That's making a line. And we're done. Okay, so if there's any things on there that I kind of tried to really explain the different things as we were going through them, but of course, let me know. I'm always here before school if you need any help. All right, kiddos. Have a good day. Bye-bye.